Today, we're diving into one of the most popular beginner projects in the robotics, the obstacle avoiding robot. To make this project, you'll need an Arduino Uno board, a motor driver, the ultrasonic sensor, which is the heart of the project, two DC motors, two wheels, a 9 volts battery, a switch, a small universal wheel, and finally a 3D printed platform, which you can find from the internet. So first, I start by cleaning the platform from the gelatin. Then, I place the screws to join the both platforms together. Now I am installing the DC motors that turn the wheels and the universal wheel onto the bottom platform. Now it's time to make the circuit. I connect the DC motors to the motor driver. I'm making the connections between the Arduino and the motor driver. Now I connect the switch to the circuit, and then we will move on to the sensor connections. Now let's make the connections between Arduino and the ultrasonic sensor. If you don't know how to use ultrasonic sensor, you can find it on my channel. Our project is almost complete. Finally, let's code. First, I use define to assign the pins for the trick pin, echo pin, and the motor control pins. This way, I can easily reference these pins throughout the code without needing to remember the numbers. In the setup function, I initialize serial communication. I also set the pin modes for the ultrasonic sensor and the motor driver pins. In the loop function, I continuously measure the distance to obstacles. I start by triggering the ultrasonic sensor. First, I set the trig pin to low for 2 microseconds, then set it to high from 10 microseconds to send out a sound wave, and finally set it back to low. Next, I use pulse in to read the echo of the sound wave from the echo pin. This function measures the time it takes for the sound wave to return, which I store in the duration variable. Then, with this mathematical function, I convert time into centimeters. After calculating the distance, I check if it is less than 20 centimeters. If it is, it means there is an obstacle nearby. In that case, I make the robot to reverse and turn right. If there is no obstacle, I make the robot move forward. And finally, I include a small delay of 100 milliseconds to stabilize the readings before the loop starts over. We are done with the code. Now let's upload the code and see what happens. As you can see on the serial monitor, as I move my hand closer to the sensor, the number decreases, and as I move it away, the number increases. This means the sensor is successfully measuring the distance. Now let's place the car on the ground and test it right away. It works perfectly. Another project is finished. If you have any question, guys, you can ask on the comments section. Thanks for watching.